Grade 12 Pre-Cal, Lesson 6.5, Graphs and Trigonometric Functions. So what we're going to do is, since we know what sine, cosine, and tangent functions look like, now we're going to start to change them. So here's the basic pattern right here. So y equals a sine b, x minus c plus d. And each of these, the a, the b, the c, and the d, do different things to a graph. Okay, so a is a vertical stretch or compression by a factor of a. So what it does is the overall height of the graph. So for instance, if there was a 3 there, it'd be 3 times as tall. If it was 1/3, it would be 1/3 times as tall. Okay, and that changes the amplitude. Remember, the amplitude is the distance from the center to either the top or the center to the bottom. Okay, now B is the tricky one. B is opposite of what you think. So if, for instance, if B was 2, right, it's a factor of a half. So 2 means it's smaller by a half. If it was a half, it means it's bigger by 2. And that changes the period of the function. Remember, the period is the time it takes to complete one cycle. And it's 2 pi over b for that one. Phase shift, C. So C is here. That one's, remember, backwards. It shifts it left and right. Right? If it was negative, it goes to the right. If it was positive, it goes to the left. Remember, because it's backwards. And D is just a vertical translation. It shifts it up or down by a specific amount. So if D was 3, it goes up 3. If D was negative 3, it goes down 3. So the functions of those also apply to cosine. So flip to the next page, and we'll do a simple example of it, so you can see what happens with this. So we have a graph y equals sine x, and then we have y equals 3 sine x. This is the A. This is the one in the front. And this is going to vertical stretch our sine curve. So here, if you look at it, here it is here. There's our normal. And this one goes negative to positive. We could do it all on the positive side. You got to pay attention to what the actual thing is. So there's 1.57, and right pi is here. So there's 180, and there's the other 180. The amplitude is 1. That's the height there. This one, the 3, everything's 3 times as tall. Now, instead of making the graph look taller, we can change the scale on this one. So the 3 on this one and the negative 3. So you can see right away we took the y value, right, and increased it by, multiplied it by 3. Okay, let's look at example 2. So what we have here is, how does cos x minus pi over 3, how does it change? Okay, so if we look at this one, this is a horizontal shift. And remember, it's backwards. So what number do we plug in there to make that thing equal to 0? Well, we plug in positive pi over 3. That's going to shift it positive pi over 3 units to the right. Okay, what about this one here? So what we have is sketch the graph of y equals sine into 2x. Now, the 2x is in the center there, over the interval negative 2 pi to 2 pi. So if you look, ignore the solid line, look at the dotted line here. So there's negative 2 pi, negative pi, 0, pi, 2 pi. And you can see that dotted line is our original sine curve over that period. Now, what we want to do is, that's a 2 there. So you think, oh, it's 2 times as wide. No, this one's backwards. It's 1 over 2. So it's half. So basically it compresses. So if you look here, you can see from 0 right here, and I'll draw it like this. That is a full cycle over pi instead of it being over 2 pi. So what you do is you divide all the x values from the original graph by 2, or multiply them by half. So the period in this case is 2 pi over 2, which is just pi. And you can see that the full period is just pi, when the full period before used to be 2 pi. And what we do is, when we draw the originals, we always draw them as dotted lines, and then we can draw the new ones as solid lines. Okay,